Thank you. Thanks for coming to our presentation today. I hope everyone's having a good conference. Start off, I just wanted to kind of give a brief introduction of ourselves. I'm Brandon Bird. I'm a systems engineer at Progressive Leasing. I've been using SaltStack for about 2 years, and like to consider myself a technologist ever since I took apart my parents' VCR at 8 years old and almost caught the house on fire. Avid gamer and okay golfer. And I'll let Mason introduce himself.
Yeah, I'm Mason, as you can probably tell on the slide. Part-time Panda, systems engineer as well. We work on the same team, although he's actually leaving us to focus a little more on some monitoring stuff. We both have been working on it for just about 2 years now. Really instrumenting Salt, getting into the nitty-gritty. Very similar upbringing, so I mean, I as well, tinker with stuff. I work on a lot of home projects in my spare time. A lot of Raspberry Pi stuff, and play games as well. So nothing super out of the ordinary or exciting, but.
And while I might be joining a different team monitoring engineering, there's still a lot of SaltStack involved, as a lot of you may know. I wanted to give a brief background of our infrastructure before I kind of jump into the project that we put together. So our infrastructure is primarily on-premise. It consists of 2 data centers, kind of split across evenly for the most part. We have roughly 350 production VMs and about 1,200 total across all environments. Some of the early problems that we had before we even implemented SaltStack a couple of years ago was, I think most people know, we have manual configurations. Everything was configured by hand. And oftentimes that leads to a lot of inconsistency. So we had a couple of things to help us with that, and I'm sure a lot of people run into this before they start using SaltStack. You may have some scripts, some specs, some runbooks to help you provision servers and make sure that they're in a known working configuration state. And that does help. We can configure 2 servers here, and they work like they should out of the box. But maybe a script forgets to get run, or someone misses a step in the runbook, and you end up with a 3rd server that's a little bit out of configuration spec. And you might also have someone kind of go into one of the servers and manually make some changes. And now we have 3 servers that, while they should all be the same, have a couple differences. And that could lead to some problems down the road. So post SaltStack, we started implementing SaltStack, started using Salt Cloud to provision our servers, and Salt States to help keep them in a known configuration. And that definitely helped. We got all of our servers kind of aligned. But early days, we had a single salt master, and everything was stored in kind of flat files. So you SSH to the salt master and edit your salt states and everything. And that often led to changes. And those changes didn't often get reflected to all the servers that may have been provisioned with that original salt state. And so now you provision a new server, and it's not quite in sync with the rest of them. A bigger problem with that is, let's say someone's making a change to a salt state, and maybe it's meant for a development environment. You're making some updates to test some new configurations, but then you accidentally push them out to production. That's great. They're now all in sync. However, it's probably not ready for prime time. So not really the best scenario. And since everything's stored on kind of a flat file, we didn't really have a way to see what changed in the salt state. So there wasn't an easy way to roll those back. So hopefully you had backups. You could roll your servers back from a previous backup state, or maybe your salt state was stored in a backup somewhere, because if you don't, let's just say it's not a pretty day in the office. So ultimately, we wanted to try and figure out, how do we get to this where everything is in a known configuration state, and we don't have those problems of not knowing what changed and being able to roll back those changes. And that leads us to our project that we kind of went through our discovery process with, leading to scalable salt state version control utilizing ServiceNow and Git with SaltStack. So real quick, I wanted to go over kind of 3 goals for this project. The first goal is being able to audit changes. So speaking earlier about not being able to roll back a salt state, we need to have the ability to know what changed in a salt state, who changed it, when it changed, and we want that ability to roll back any changes if it's not ready for prime time. Maintainability, we want to be able to easily maintain our salt states and be able to test any salt states in a lower development environment before rolling them into production. And then server parity, we want to be able to keep our servers in a known configuration state. So with the first goal in mind, auditing changes, we started looking at Git and utilizing GitFS with SaltStack. And real quick, why would we choose Git? For those that may not have used Git, I'm sure pretty much 99.9% of us all know what Git is, but it gives us that data integrity and gives us that ability to track changes on our files. So it was a clear winner for auditing changes. And then why GitFS? Well, it's a native solution. SaltMaster actually has a GitFS configuration that all you have to do is configure your mount point and configure your repo endpoint, and kind of away you go. And it does support those branches and tags, so it gives us that ability to push specific branches or specific versions to lower environments without affecting production. But as we started going down the route of utilizing GitFS, we did start running into some problems. One problem that we ran into was every time we would add a new repo, we'd have to go and update the SaltMaster config. So all of our salt states were actually stored in a separate repo for each one. So the Nginx state would be in its own repo, the Apache state would be in its own repo. And this led to a very large SaltMaster config for the GitFS configs, because you'd have to have a new mount point for every single state, which pointed at each individual repo. Not a huge deal, but it was a little bit cumbersome, and you'd also have to restart the SaltMaster every time you did that, which not ideal, because if someone's actually utilizing the SaltMaster, maybe they're deploying a new server or something, you just killed their service and they have to start all over. So the one question that came to mind, well, why don't we just put everything into a single repo? And we thought about doing that, but then we had a bigger problem with maintaining version control. If you're just utilizing branches, this may not be a huge deal because you could have a dev, QA, RC, and prod branch. But we wanted to be able to use version tags to maintain a version on our salt states. And it got really convoluted really fast, because if you made a change to Nginx, wrapped it into a version, then you go and make a change to something like Linux base, and so on and so on, you end up with a whole bunch of version tags. Technically, the Nginx version 2 tag contains the same tag as the Linux base version 3, and so on and so on. Again, it just gets really convoluted and really hard to maintain, so it wasn't really ideal for our situation. Another bigger problem was that we found the more repos we added to the GitFS config, the slower our salt minion state returns became. So we actually did crunch some numbers and did some examples here. If we had one repo, it was okay. We got some pretty fast returns. Add 10 repos, it got slower. 50 repos got slower. 100 repos, it just spikes. And a lot of people, not a lot, but some people may not have that issue, but we had a lot of salt states ever growing for all of our different roles and our different needs. And if we're trying to manage all those in GitFS, it just became unmanageable to deploy them to salt minions. And that often led to, because it was so slow, if you started targeting more than one minion, you ended up getting to a point where you didn't even get a return. The SaltMaster would just kind of time out, and you basically get an error. So you could run it in async and then go check the job later, but sometimes that would take up to an hour, and that wasn't really maintainable, especially if you want to push out a deploy and you actually wanted to go to bed that night. So a solution that we kind of kicked around the idea of, well, why don't we just kind of clone all the repos locally? We found that running all of the repos, let's say we had 100 repos, remotely took forever, where locally cut it by about 90%. So it was a huge win to just have all of our salt states local. But the clear problem with that was, how do we maintain all of those repos on the master locally? Can't just go out and do a git dash pull every single time you do an update. That kind of becomes cumbersome itself. We kicked around the idea of, well, we could just run a simple script in a cron job, but then how frequently do you do that? How long does it take to do that? Especially if you have 100 repos, is it going to go to every repo and do a git pull every single time? So I don't know if that's really the best way to do it, as well as if you make a new commit, how long is it going to be before that salt state is actually ready to use from the salt master without manually going and doing another pull? And then another issue is how do we utilize those different branches and version tags that we just talked about? So if I clone them down and I've cloned down master, what if I want to use the dev branch, or what if I want to use a specific version tag? Do I have to then check out that version tag for that one state every time? But then what if I accidentally push the wrong version? So not really ideal. And that kind of leads us into our next step, which we started looking at utilizing a CI/CD pipeline to help deploy our salt states, which I'm actually going to pass it off to Mason as he helped kind of develop and architect this with me.
Yeah, so this whole CI/CD thing shouldn't really be super new. Any of you who've worked in large-scale development environments, it's something that in infrastructure I think we don't see as frequently as pure code development. But I mean, a lot of those principles that it can provide are really helpful for solving a lot of these problems. So, why would you want to take this kind of an approach? There's a few really key benefits that it can bring about. For example, it's really lightweight in comparison to running a cron job that iterates over all of your different repositories, tries to fetch and pull any changes. You've got a process now that if you've got a couple hundred repositories, that script might take quite a while just for the overhead to go through all of them. Whereas in a CI or CD pipeline, you don't have to go through everything other than what's been changed. It's triggered as a result of that change being pushed to your repository, and so just that repo is updated. You can have any number of repositories that you want, and they'll all still take the same amount of time to deploy. On that note, it's really fast. You don't have to worry about waiting for a cron job that runs on a 5-minute schedule, maybe an hour schedule. However, would work for you. It's within, in our case, usually a few seconds of you pushing the code up or approving a merge request. It's already pushed down and cloned to the salt master. So it's usually faster than you are to get back to the terminal and try and run your states or whatever have you. And it's really expandable because of these things. So it makes it really easy to shoehorn in extra steps into the pipeline. We'll look at linting, for example. We have some really primitive check work that's done so that really basic problems aren't introduced to our environment. But you can really, extend this however you want, add as many stages, integrate with other services, all as part of this. So various CI/CD services exist. I'm sure you've used plenty of them. In our case, we went with GitLab just because that's what was already hosting our Git repositories. So it made a lot of sense rather than trying to introduce a whole new tool. So we'll be using GitLab specific terminology here, but really anything that performs CI should have very similar concepts. So we just have 2 stages that we perform in our setup. We have a lint stage that goes through and validates that syntactically your state's correct, and then assuming that it passes that, it'll actually deploy that state to the salt master. The linting's really simple. We just run it through a show SLS function. There's a lot of different options you could take here. This is what we've gone with so far because it catches most basic errors. It doesn't involve a lot of convoluted setup. We don't have to maintain unit tests, although we'll probably be moving in that direction later on. But this way, it'll catch any major errors. If you pass the return code pass-through flag as well to the salt call, it will then feed that back to your CI pipeline and indicate a failure, so you don't end up deploying anything that doesn't render correctly in salt. We also have some options in here so that internally we use a work in progress branch for any sort of testing we might want to do. And this way we can add a key here to allow failure on that branch. That way, even if there is a syntax error, maybe we're trying to check a specific state in the folder, maybe we're trying to check just a specific piece. You don't have to worry about your work in progress changes being completely subject to the scrutiny of production environments, so it doesn't slow down development time. Deploying is really straightforward as well. There's several ways that we thought about tackling the problem. Obviously, needing to access all of the different branches and tags, you can't just clone it to a single folder without then having to worry about trying to check out whichever branch or tag you might need. So we could map them each to their own Salt environment. That might look something like you would expect in sort of a GitFS type fashion, where you, underneath your Salt directory, map each branch or tag to its own folder and then deploy within that. Then you can utilize that in just the native Salt environment method of adding an extra flag whenever you need to pull that version of a state, and it works pretty easily. But there's a few main drawbacks that we'll look at that ended up pushing us towards the second option here, where we map everything under a single Salt environment and instead deploy the branches and tags as subfolders of the main state. This way, when you're applying states, you can just add a dot there, and very much like you were trying to traverse, subfolders if you have embedded Salt states, it works in very much the same way. You can still access all of the same files. And really, that solves a lot more problems, because the bigger issue we ran into with trying to deploy in that first methodology was very similar to the GitFS problems. You might have a Salt environment, let's say V3, but your V3 release of certain Salt states might not correlate to the V3 release of other states. So now you have to worry about explicitly defining all of your Salt environments in many different states and updating those and maintaining those, and it just gets to be really problematic. So the second approach made more sense to us. We just use GitLab runners to facilitate this. They're very much like Jenkins slaves or any other CI/CD system that you might have run into before. They really, in our case, just have two scripts that we use. We have a CI configuration that utilizes this first deploy state script, and that script really just calls another script on the Salt master via SSH to then go and pull through everything. And this is a little wordy, so I don't want to go through all of the details. If you guys have specific questions about how this works or want to see the code, we'll have email available so you can ask us directly. But ultimately, all that happens is this Salt states are updated via these scripts being called on the Salt master. We looked into maybe running the GitLab agent directly on the Salt master. That way you could bypass the need for this extra script of passing through to the Salt master which parameters to go fetch, but ultimately decided that running some extra software on our Salt masters wasn't really what we wanted to do for security standpoints. It's not super modular. If we need to scale outwards, if our Salt masters need to serve more dedicated purposes, having these extra agents on there just really isn't beneficial. So the other main problem with this approach, trying to deploy via subfolders, is trying to access any files, static files, trying to manage files. Salt URIs became sort of strange to try and work with. You'd have to basically make changes every time you switched which branch you wanted to access these files on, just so that they would pull the correct local version, and you could actually have instanced files across all of your different tags. You don't have to share them across every state. The easiest way we came across fixing this was just using a regular expression. So there's just a little piece towards the end of the deploy script. After it pulls all the changes, it looks for any Salt URIs that match the format of the deployed path without the subfolder that indicates which tag it would be in, and it just replaces and injects it straight in the end there. So it shows up easily, seamlessly. You don't have to worry about managing these manually, and it won't change anything that might be pointing to another state. So our CI/CD pipelines as well are really visible. It's a nice way to get an idea of where in different stages your Salt state work might have had problems. Everything's very transparent, so it's really easy within GitLab to see where problems might have showed up. Here we can see a Salt state that didn't lint properly, and so it wasn't deployed because it was trying to push to a master branch, and that way we didn't end up pushing code errors to production. So really nice, convenient output as well for every one of these states. You can see exactly what was run, the output, just like you were sitting on the console yourself. So it makes it really easy to go back and audit these, keep them for any sort of record keeping. it's really handy as well to look at failures this way. You don't have to then comb through all sorts of logs and try and figure out where your problems are coming up. It's really easily shown in a simple, easy to view stage. We spent lots of time before this trying to pin down areas that problems were cropping up. So this was just much easier. And so between all these things, it solved really all of our use case problems of trying to hit that scalable Git sort of deployment. But the main problem we still had was correlating where servers would get the information of which versions of which salt states they needed to run. And so to facilitate that, we ended up looking towards Snow's CMDB. And I'm going to give it back over to Brandon because he's really the brain behind this. So.
All right, so we talked about auditing our salt states utilizing Git, and then maintaining our salt states using a CI/CD pipeline. So really, the last piece is how do we make sure that all our servers stay in parity? How do they stay running the same config, the known config that we know they should be running? So first, I just want to talk about what is a CMDB, and that CMDB stands for Configuration Management Database, for those that don't know. It basically contains all of the hardware, software, and applications for your IT services and the relationships between all of them. And then why would we want to use a CMDB for this? Well, the manageability. It gives us that easy viewpoint of our server's configurations. So because it's a configuration management database, it's really easy to consume for anyone who's not even technical. You'd have a simple form that would show you what the configuration actually is. And then the integration piece, it easily integrates with SaltStack. One of the things I absolutely love about SaltStack is just how easy it is to integrate pretty much any tool that you have. And in our case, we had a CMDB and we wanted to utilize that with SaltStack. So I'm going to talk a little bit about our integration with CMDB and SaltStack. We use a tool called ServiceNow, and ServiceNow has a module for CMDB, and that's currently what we use as our CMDB. We created a two-way integration between ServiceNow and SaltStack. So on the SaltStack side of things, we actually created a custom module to connect to ServiceNow's RESTful API. And on the ServiceNow side, we created a custom endpoint and some custom scripts to connect to SaltStack through Salt API using the Cherry Pie module. And this gives us that kind of front end piece to see our server configurations, be able to provision new servers and update existing servers and keep them in a known configuration state. So basically ServiceNow is that front end piece as far as this is our visualization. This is where we're going to make sure that everything that it's configured with is correct. And then SaltStack becomes our orchestration piece underneath all that to make sure that they are actually running a known configuration. So I'm going to go a little bit about how we accomplish this. So we created a custom CI, which is a configuration item within CMDB. Called a server template. And this contains basically the configuration for any server that we would want to provision or stand up. For those that are familiar with setting up Salt Cloud profiles, so our environment consists of on-premise VM utilizing VMware as our cloud solution, on-premise cloud solution. We have a VM profile, and the VM profile is essentially a Salt Cloud profile. That tells it basically what data center it's going to be, stand up the server and things like that. And then you'll notice all of these options here are essentially just Salt Cloud options for the VMware configuration. And these can be configured for any Salt Cloud installation that you have. And basically what we do with this information is ServiceNow will take this all, compile it into a dictionary, and send it over Salt API as inline pillar data that you can then utilize for Salt Cloud override. One key point here that isn't necessarily in a Salt Cloud profile is we do put our salt state configurations in here. So going back to utilizing Git and having every salt state in its own repo, we have our salt states that we want this server to be provisioned with. And we're utilizing something like a base state for Linux or Windows that just kind of has all the base configurations for that. And then we have some role states depending on what we want the server to actually do in the end. And then we also have over on the right there, on your right, my left, the versions for each of those states. So this gives us that version control to make sure that whatever version of that state we want to deploy is what will actually get applied to the server once it's provisioned. And then we do have something here. This is completely optional, but it's something that we think is pretty cool, is on the ServiceNow side of things, we can utilize those custom scripts to do something like have a simple build button. And that will literally just connect to Salt API, provision the server for us all on the back end, and then ServiceNow can receive the return codes, and we can then kind of do what we want with those return codes, which I'm going to actually show in a workflow here in a bit. So a simple build workflow, what it would look like on our side is in ServiceNow, we build that server template, click that little build button. That's going to kick off the ServiceNow script to connect to Salt API and pass it that inline pillar data for the Salt Cloud overrides. And that's going to call an orchestration state on SaltStack side. That orchestration state will have the Salt Cloud commands for provisioning the server, and then apply the salt states once that server is actually provisioned. And once it's all finished, it's actually going to send the return output back to ServiceNow. Now, depending on what that return output is, if it's true, we could do something like we'll create a server CI now, server's up, it's running, and we'll notify the user saying, hey, everything's good, it's ready to go. If it's false, we could do something like create an incident letting the engineers know, hey, server didn't quite provision right, here's the return code, go ahead and kind of fix whatever happened with it. And lastly, because we want to keep our server CI in ServiceNow linked with unique identifiers to SaltStack's minion, we can connect back to Salt API and actually set some custom grains on that minion. And that way, SaltStack in the future, whenever it needs to check on that server CI, or vice versa, the server CI in ServiceNow needs to connect back to the SaltStack minion, it can use that unique identifier. And I just wanted to show real quick an example of what a server CI looks like. So after the server's been provisioned and we got a successful return and notified the user that it's up and running, we have this server CI in CMDB that we can then go back through and look at to see what its configurations are, and more importantly, what its salt state configurations are. So our implementation, we tie each server to a server template that it was provisioned with, and that has the salt states that are configured for it. Now, if we ever wanted to go through and then update the salt states on that server to a new version, depending, we might have to rebuild it, which is fine. We can just rebuild a new server from that server template. Or if we can update it with a new config, we can update the server template, and then we could go through on the ServiceNow side and connect to Salt and kind of do some checks to make sure it's running the latest configuration that you have configured for it. So as an example of what that workflow would look like, if we're going to update the minion, we would update the salt states in ServiceNow. If it's production, hopefully you would put in some change tickets, actually go through a cab and whatnot, and make sure that it's vetted and ready to go. That would connect to Salt API, and then on the minions that it's configured for, it would actually apply those new updates, send its return code back to ServiceNow, and depending on what you get, if it's true, notify the user, hey, everything's good, we're up to date, we're running the latest version. If it's false, you could do something again where you create another incident going, hey, something didn't quite apply right, you might want to go check this out. And then kind of more importantly, going back to the auditing facets, wanting to make sure that all of our servers are in a known configuration state, because who knows, you may still have a developer, an engineer, someone that goes manually onto a server and updates the configuration. that now puts it out of sync with what it should be configured. We can actually have SaltStack start on the SaltStack side, and that can check ServiceNow for the server CI that it's the minion's associated with. And it'll pull that server CI data that we looked at with the salt configs, send that back to SaltStack. SaltStack could do something where it verifies the state, doing something like a test equals true, seeing if there's any changes or if everything's in a known configuration state. If there's no changes, then we're all good and we can just kind of go on our way. And if there are changes, then we probably have a problem because it's no longer in the configuration we thought it was in. And we can connect back to ServiceNow, create an incident saying, hey, we need to resolve this. What do you want to do? You could do some stuff in there where you automatically resolve it, where maybe we use a reactor that just continually checks this version. And if it's out of sync, just go ahead and put it right back into the right configuration. In our early use cases, we wanted to make sure that we had some manual intervention just to make sure we didn't break anything into production. But there's definitely a lot of expandability that you can do here. So just to recap on the goals that we kind of went over, we talked about auditing changes, and we utilized Git to provide us that data integrity and that tracking of our files so that we know what changed, who changed it, when it changed. Maintainability. We used a CI/CD pipeline to help us maintain our salt states on our salt masters and maintain all the different versions and branches that we have. And then server parity, we integrated with ServiceNow CMDB to help us keep our servers in a known configuration state. Real quick, just a little plug that I want to put in here. So we built a custom connector for ServiceNow and SaltStack, utilizing a custom module and some custom scripts. If you are a SaltStack Enterprise user, I was actually just made aware recently that apparently either in the current release of SaltStack Enterprise or in a very soon to be released SaltStack Enterprise, they're working on a connector for ServiceNow. I don't know exactly all the details of what that'll entail, but if you do use SaltStack Enterprise, you can talk with your vendor, your representative, and I'm sure he could give you some more details on that. So with that, just a little shameless plug here. If you like the technology that you see and you want to work on really cool technology, we are located here, headquarters are located here in Salt Lake, just down in Draper. But we are actively hiring technologists in pretty much all departments, developers, engineers, whatever. You can find us at jobs.progleasing.com. And as far as that goes, is there any questions? Yes, I'll bring the mic to you.
So at the outset, you kind of said one of the goals was being able to approve any changes that are made to your salt states. And I see that you kind of have like an automated way of doing that, like the linting and then having the states broken up into like the different branches. Is there any point in that process, is there a manual like, yes, we approve of this salt state to go in, or no, we decline, or you just completely trust the CI/CD pipeline like through Git?
I can answer that up here, actually. We have we do use merge requests in GitLab for that. So it'll submit a pipeline previewing what would happen after the changes were merged, and then you can approve them, and then it'll actually go through and facilitate the deployment at that point. So you can configure that as well within GitLab, but depending on your CI solution, there's different mechanisms there. So in our case, anything up to the master branch, we generally don't care too much, or specific release tags we'll care about. Any creation of those release tags or merges up to the master branch do have a manual step, though, it'll trigger an email that signals everybody else on the team that there's something to be approved.
So you mentioned that you do have a master branch. So on the actual salt master, do you have like a mass, like, because you've broken up to like SRV salt, and then I think then after that was like the name of the formula and then the branch and the tag. Do you also have an actual master directory in there, or how do you have like the master branch on the actual salt master?
Yeah, it just gets deployed under the master name, so you can type out the full name of the state, and then .master would be the up-to-date master branch. In our use case specifically, we really work hard not to have any production dependencies on active master branches. So we typically don't use it for much other than active development. So once we know for sure that something's working through a lot of testing, then we'll commit to an official release and then tag that and use that in our production use case.
Do we have another question? Couple. Go to you first.
Hi, I noticed that the only mention I heard of pillar throughout was inline, and I'm curious, sometimes salt changes, are really tightly linked to a corresponding pillar change. Is there a built-in mechanism for handling that situation, or do you even use this approach with pillar, or do you need to, know to pick the right version? Is that relying on humans?
Yeah, so we, in our environment, only really have one flat pillar environment. We don't sub-base into separate pillar environments. Generally, it's a really big static pillar, but for anything that we need to pass that's inline, it's facilitated through that script as well. Really, any of the state applications are unchanged, so anything you might need to run to pass inline pillar to a state or to access a specific pillar environment, you would do in essentially the same way. If your linting really gets much more complicated, then yeah, trying to just do a show SLS won't work super easily to pass all that pillar data through. So you'd probably have to worry more about writing strict unit tests or look at, I think there's a salt lint module that someone's written on GitHub, but I haven't had time to really delve into it. So I don't know much beyond that. But other than that, once it's deployed, as far as how you would implement pillar usage, it's really still handled the same way as you would with GitFS or just with local files. So.
And then our Git, our pillar, we do have, I think you talked about this, but we do utilize an external pillar with GitFS as well. So there's some version control around all of our pillar. So, thank you. You have a question?
Do you have your configuration files under source control? And if you have them, how do you restart the master or when?
Yeah, so the nice thing about keeping everything locally deployed like that, obviously all of the files themselves are in their own Git repositories. So if ever there's changes made to a state, we can just look at that Git repository's history, see if we need to roll back somewhere, see what changes were made as part of what commits. So in that way, yeah, the files themselves are audited through that, and then as far as restarting the salt master, there's not much need to. If you're deploying locally like this, if you were to deploy while something was using the files, it can interrupt existing processes, but in our use case, that doesn't really come up much. There's no race condition to be worried about. So it doesn't need to even be restarted because the salt master, it just looks up the file whenever it needs to use it. And so it's immediately made available. You don't have to worry about restarting to try and get new GitFS objects to show up. So it's really pretty much immediate.
The file that I'm talking about is the master configuration itself. For example, if you want to increase the worker threads or the reactor threads.
Yeah, we don't manage that in Git at the moment. It's something that we could really easily do about the same way. If you were to do that, then yeah, you'd probably need to worry more about including some steps in your pipeline to handle restarting the service. But as it is now, our Git configuration, our salt master configuration rather, stays really more or less consistent. We don't see ourselves changing it more than every few weeks at the moment. If you were in an environment where you needed much more dynamic changes, then you could probably utilize a lot of these same concepts. You would just need to make sure that you could facilitate being able to restart your salt master under whatever conditions you may have, if that's manual review for those merge requests, so that your pipeline's triggered, so that you make sure that you're only restarting it during hours that you're acceptable to perform maintenance. Then that's probably about the easiest way that I would imagine facilitating that.
Okay. One last question.
Mm-hmm.
Did you evaluate deploying your salt master using Docker containers?
No, we don't really use containerization for our Salt environment at the moment. It's something we're exploring a little bit, but at the moment, everything runs natively on our Salt master is CentOS 8 box, and everything. We have both Windows and Linux minions, but nothing's containerized beyond that. So,
Thank you.
anything else?
Another question over here.
So I know you said, again, one of the main goals is, so if you have state files that need to be different in different environments, through like dev, staging, release candidate, production, that's why you have this version control and the branches. But how do you tell, like, what steps do you go about to tell the Salt master, okay, now anything you're doing in the staging environment uses these tags for the state files?
So that calls back more to Brandon's work with the CMDB. In our case, it really comes down to having separate templates for each environment, and that way you can one-to-one correlate which tags of which salt states need to apply to which environments of which server types.
Yeah, so our ServiceNow CMDB becomes that record of authority as far as what states and what versions of that state should be applied to each minion.
Anyone else?
Any other questions? Yeah.
Were you guys already using ServiceNow? And that's, or did you guys pick them specifically for their CMDB?
Good question. We were already using ServiceNow, and we needed a CMDB, and it so happened that they did have a CMDB module. So, you have a question?
How much admin control do you need over ServiceNow to be able to make these type of modifications?
That is a great question. Honestly, you pretty much need full admin control and some variety, because there's a lot of custom scripts on the back end that you need to go in and create. So if you have ServiceNow developers, you might need to work directly with them. But yeah.
But yeah, these concepts aren't unique to ServiceNow as well. You can really anything that you can use as a CMDB, as long as you can facilitate mapping that relationship, it works in about the same way. So
yeah. And you might even be able to set up like a custom dev instance for yourself, because they do have like a free version of ServiceNow that you could probably work with, and then you could work with your developers. Not the best case scenario, but yeah. Yeah. Any other questions? All right, real quick. If anyone does have further questions, you can find us on LinkedIn, and our email addresses are there. But other than that, thank you guys for showing up and coming.